Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Consonant Intervals by Scrufamuda. And here are the rules. We have normal Sudoku rules apply, which means we need to place a single digit in every cell in this grid from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, in this case a box. Digits joined by a letter are in a ratio to be determined by the solver. And each letter, C, D, F, and G, all consonants, represents a unique ratio. I wonder why he skips B, though. I don't know. B is a consonant also, but it just got completely removed or just completely ignored. Anyways, right. So each letter represents a unique ratio. So that means if the C could be a 1 to 2 ratio, but if C is 1 to 2, that means no other letter from D, F, or G can be 1 to 2, right? So if C were 2 and this was a 4, this would be a 2 or an 8 to maintain the 1 to 2 ratio between those digits. Anyways, those are all the rules. If you like, it's a unique ratio though. It's not necessarily a number. So keep that in mind. It's not necessarily a number because he said specifically a unique ratio. It's not a unique digit. So C could actually be something like 3 to 2, or 2 to 3, or 3 to 4, or 5 to 7, technically. And those would all be possible unique ratios again. So remember that. And those are all the rules. Right now, I'm going to go to the bathroom, so I'll be right back. Okay, and I'm back. And so, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. One thing that's interesting is we have C, which is a unique ratio between 6 of the digits. I don't think 5 and 7 can ever be part of those. 5 would be like 5 to 1 ratio, or 5 to 2, or 5 to 3, but the problem is no other digits can actually fulfill that, right? We also have G and D. G has two ratios of that are, or a single digit that has two ratios that are in 1 to 2. That's in that ratio twice, essentially, with another digit. And then a single digit pair, which fulfills that. But to have 6 unique digits all have that same ratio, I think C has to be 2 to 1, would be my guess. You can't have 5. 5 goes to 5 to 1 doesn't work because then you have 2 and 10, which doesn't work. 5 and 7, 5 and 2 obviously doesn't work. Wait, I think we did that. No, 5 to 2 doesn't work because then you have 4 and 10. Basically, 5 with any combination just doesn't seem to work. 7 has the same problem, right? 7 to 2, 7 to 1. If you try to get to another ratio, you have 2 and 14 at the minimum, which doesn't work. If you try to have 7 and 2, you get 4 and 14, same problem. So 5 and 7 can never be in that set. So 5 and 7 have to be here. This is very likely 2. What other one could be? Can you ever have a 9 be with something else? 9 could be in a 1 to... You can't have a 1 to 9 ratio because 9 to 1... Yeah, you'd have to essentially be divided by 3 there, right? So 9 with some ratio of another digit. So that would be... Can't be 9 to 1. Could be 9 to 3 technically. 9 to 6 also works as a 3 to 2 pair. And I think those are the only ones. So it's 3 to 2 or it's 3 are also possibilities. But 4 can never be in a 1 to 3 ratio. 8 can never be in a 1 to 3 ratio with another digit. So that cannot be 3 to 1 there. 3 to 2 doesn't work either, right? If you have 3 to 2, I think it just doesn't work, right? 3 to 2, you would have 9 to 6. 4 could work with a 6, but you'd also have 9 to 6 again, which is the problem, right? 8 could never be in a position. 8 would have to be with 12. 2 could be with 3. 1 would never be possible. So, yeah, you would have 1 and 8 could not be in a 3 to 2 ratio in relationship. So this must be 1 to 2. Therefore, this is 5, 7, 9 here. And this must be 1, 2 with 1 and 2 together, 4 and 8 together, or 3 and 6 together. So this is a 1 to 2 ratio. G has 5 digits, one which is in which is in ratios with 2 other digits. So I think those are specifically 3 to 1 or 3 to 2, or 2 to 3 or 1 to 3, however you parse it that way. I think those are the only ones that work. 4 to 1 seems too large. 4 to 3? Maybe 4 to 3 might work. 4 to 1. If you have 1 to 4, that doesn't work because 4 would have to go to 16. What about 4 to 3? If you have 3 and 4, 4 would act as the 3 digit. That doesn't seem to work either. Right? 4 to 3 would be either 4, 3 or 8, 6. 6 is not in a 4 to 3 ratio with another digit. Yeah, so it has to be, G has to be either 3 as a 1 to 3 as a ratio or 2 to 3 as a ratio. When same with D. D is 3 to 1 or 3 to 2. Okay. If D is 3 to 1, that means this is 1, 3, and 9 here, right? So 9 could not be here. 9 would have to be here. This would be 3, and that would be 1. The other 1 to 3 ratio would be 2 and 6. So that would be 2 and 6 there. So that's if D is the 1 to 3. If D is 2 to 3, I think that works, right? You have 9 to 6, which is a 2 to 3 ratio, and 6 to 4, which is a 2 to 3 ratio. Either way, you have to have a 9, and 9 cannot be here because of the 5, 7, 9 triplet. So this is guaranteed to be a 9. This is 9, and it's either 3, 1, or this is 6 and 4, right? Any other ratio just doesn't fit. 4 to 3, the 4 to 3, you only have four possibilities, right? It's 4 and 3, and then 8 and 6. There's no other ratio that works for that. For 3 to 2, you have obviously 3 and 2. You have 6, 4, and you have 9, 6. So either way, this is 9 here. We have to have a 9 in one of these. So this is 9, 3, 1. So this is either 2 and 6 or 2 and 3 here. We now have in box, so this is similar then. This is 9, 3, 1, or 1, 9, 3, 1, or 9, 6, 4, or 9, 6, 4. And this is 2 with 3 or 6 here. Well, this can never be 2 because one of these digits is a 2 here. This can't be 2 here because one of these two digits is a 2. Therefore, this is guaranteed to be a 2 here. Okay, so G is either 3 to 2 ratio, and so G and D are 3 to 2 or 1 to 3 ratio. F, we have two F ratios. And it cannot be 1 to 2, cannot be 3 to 1, cannot be 2 to 3. Does 1 to 4 ever work? Yes. It could be 1, 4, and 2, 8. So 1 to 4 could work. 3 to 4 could work. Right? Because you could have 3 to 4 and 6 and 8. Anything higher, I think, does not work. Anything higher than a 4, you cannot ever have two ratios of. Right? Because if you had two ratios of that, you have to essentially double those ratios. So the ratios, again, you can't have 1 to 1 because you have two digits in the same row or the same column. And normal Sudoku rules would prevent that. You have 1 to 2, 1 to 3, 1 to 4, but you can't have 1 to 5. Once you have 1 to 5, the only other possible combination that has two sets would be 1, 5, and 2, 10, which is obviously not going to work because 10 is not a digit. So anything above 5 just doesn't work because you always will double essentially that the parts of the ratio. And 5 doubled is 10, so that's never going to work. So it has to have the ratios have to be from 1 through 4. So we've tried 1 doesn't work obviously because of normal Sudoku rules. We have a 1 2, which is in the C. We have a 1 3, which is either D or G. We do not have a 1 4 yet, so 1 4 could be F. 2 3 is in D or G, so that's already taken. 2 4 is the same as 1 and 2, so that's not allowed. And obviously can't be 2 5. So the only one left is then 3 and 4. So this is 4 to 1, or it's 4 to what? It's 4 to 1 or it's 4 to 3 as the ratio. If it's 4 to 1, that means you have the pair 1 4 and 2 8. Well, 2 cannot be here, so 2 would have to be here. 2 would be next to an 8, so 8 would be here. If you have a 4 to 3 ratio, it's either 4 3 or 8 6. Huh. Interesting. So we know 9 has to be one of these two digits here. This is 9. One of these is 9. So 9 could be here. 9 cannot be in the F situation. It could be in the D. So if this is 4 and 3, you have 3, 4, and then you have 8, 6. So 8 could be any of those positions there then. F has to be 1, 2, 3. Okay, so you have to have 1, 2, 3, 4, 6, and 8 next to an F. And we're guaranteed that I think the 4 and the 8 have to be there, right? You have 4 singled, and then you have the 4 doubled. So 4 and 8 always have to be in the F. If you have 4 of the unique digits, you always have 4 and 8 in one of those sets. Okay. The remaining digits in column... Well, what are we missing in box 7? In column 3, you can't have a 5, 7, or 9. You have a 2, 3, 6 triplet, where is the 5 and the 7? They have to be in these two cells. So this is 5 or 7. This must be a 1, 4, 8 triplet then in box 7. That eliminates 1, 4, and 8 in the rest of the column. That leaves these digits as 2, 3, and 6. Okay. So this must be a 4 or an 8 here, guaranteed. Because 4 and 8 in the 4 to 1 or the 1 to 4 or the 3 to 4 ratio can never be next to each other. 4 could be with 2. No. 4 has to be with 1 in the 4 to 4 ratio. 8 could be with 2. 8 could be with 6. 4 could be with 3 here. D is in... It's either a 3 to 1 or it's a 2 to 3... 1 to 3 or 2 to 3 ratio. So okay, you cannot have 2, 3, or 6 here because of the 2, 3, 6 triplet in the box. So this D is 2 to 3 or it's 1 to 3. If it's 2 to 3, this would be 2 and 3, but this can never be 2. If it's 3 to 1, it could be 1, 3 or 9, 3. It could be, if it's 2 to 3, 2 cannot be here because of the 2, 3 pair already. 2, 3, 6 triplet in the box. Or it could be 9 and 6. So this is 1 and 3 or 9 and 3, or it's 9 and 6. And we don't know what the difference is. Okay. Okay. So this C cannot be 3 and 6. If this is 3 and 6, that would eliminate all possibilities for that cell. So this is either 1, 2, or 4, 8 here. We don't know about this one. 3 and 6 has to be some combination here. So it's either this is both 3 and 6, which forces this to be 2. Or these are both 3 and 6, which forces this to be 2. We already knew one of these was 2, though. The rest of row 8 cannot be 2, 3, 6, or 9. So we're missing 1, 4, 5, 7, 8. This obviously can't be 7 because of the 7 in the column. 4 and 8 cannot be here. Oh, this can't be a 4-8 pair. If this is a 4-8 pair, the problem is this cell would be eliminated from having any possibilities. So this must be 1 and 2. This 1-2 pair eliminates 1 and 2 in the rest of the column. This can't be 2. This can't be 1. Therefore, this is a 9. 9 can be either in a 3 to 6 ratio here. This cannot be 3 or 6, so this must be a 4-8 pair, which means this is a 4-8 pair adding in a 1 to 2 ratio. This is a 3-6 pair. That forces this to be a 2. We have a 4-8 pair in column 2, a 3-6 pair, and a 1-2 pair. That forces this to be 5 or 7. So we have a 5-7 pair there. 1 is one of these. It's 1, 4, 5, 7, 8. This can't be 7, obviously, because there's 7 in the row. Okay. Okay, so this digit is exactly the same as that digit. Okay, let's look. Maybe we can figure something out from that. I'm gonna make this red and yellow here. Therefore, this is red. We don't know which one of these are there. This we're gonna make pink, and I guess we'll make, okay, let's make this pink and this orange. Therefore, this is orange. It has to match this one. Hmm. Do we have anything else? This is a 1 to 2 ratio. Cannot be 3 and 6 because that would eliminate all possibilities for that cell. So this cannot be 3 and 6. This cannot be 1 because that would be in a 1 to 2 ratio with nothing. Because 2 can't be here. Where are 5 and 7 in column 8? They can't be next to an F ratio. They can't be next to C or G. So they have to be here. So this is a 5-7 pair here. We have a 5-7-5-7 pair in row 4, which eliminates 5 and 7 in the rest of the row. This can't be 5 or 7. G, again, is in a 3 to 1 or a 2 to 3 ratio. We're not sure which. F is 4 to 1 or 3 to 4. We're not sure which. Okay. 9 cannot be next to the F. Okay. Then we have 5 and 7. We're going to mark... Okay, so this one we're going to mark dark, and this will be medium, I guess. So this is dark, which means this is a medium, and this is dark. So medium has to be one of these two. That doesn't tell us very much. Okay, so the 5 in box 5 cannot be next to any of the ratios. So the 5 has to be one of these 3. We're not sure which, though. We have, okay, where are 3 and 6 in row 7? It cannot be here, it cannot be here because of the 3-6 pair in that box. It cannot be here because of the 3-6 pair in that box, so it must be here somewhere. It could be with the G, but we don't know. Right? It's very likely one of them is the G, is in the G ratio, but we don't know. Okay. What are the possibilities here? We know this cannot have a 9. It's 1, 2, 3, 4, 6, and 8. This cannot be 4 and 8. If this was 4 and 8, that would eliminate all possibilities for this 1 to 4 or 3 to 4 ratio. Right? 4 would have to be with 1 or 8 or 3. 8 would be with 2 or 6. So this cannot have an 8. Therefore, we are guaranteed this is a 2. Right? This is a 1-4 pair. The only one with a 1 to 2 ratio with 1 or 4 is 2. So this is 2. This cannot be 2. Because this cannot be 2, you can't have 1-4 and 2-8 be the pairs here. Therefore, it must be a 3 to 4 and 3 to 4 ratio. So it's 3, 4, 6, 8. This cannot be 2. This becomes 3, 4, 6, and 8 as possibilities. That means we have a 3, 4, 6, 8 quadruplet in row 6, which eliminates 3, 4, 6, and 8 in the rest of that row. 2 has to be one of these digits here, because, again, 2 cannot be in that F ratio, because it's 4 to 3. So this must be a 2 here. The rest of row 6 must be 1, 2, 5, 7, 9. And 7 can't be here, obviously. This is 1, 2, 5, 7, 9. This can't be 2 either. 5 can never be next to a G, so 5 would not be here. This is 3, 4, 6, and 8. The remaining digits in box 3 have to be 1, 2, 5, 7, 9, right? 1, 2, 5, 7, 9. 1, 5, 7, 9 here. That means we're missing 3 and 6 here also. Interesting. Well, what does that mean in column 8? We have a 3, 4, 6, 8 quadruplet in column 8, which eliminates 3, 4, 6, and 8 in the rest of the column. This can't be 4. This has to be a 1, 9 pair. 1 and 9 are only in a ratio with 3 to be in the same ratio. So this is 3. This becomes 6 and 4. This is 2 and 3. D is 2 to 3 ratio. G is 1 to 3 ratio. So this must be a 6 also. This is 6. This is 3. 3F is in a 3 to 4 ratio. So this is 3 and 4. This 4 eliminates 4 here. So this is 8. This is 4. These obviously cannot be 4 here. And we don't know about 5, 5, 7. This can't be 3 or 4. This becomes a 6, 8 pair, which eliminates 6 and 8 from the rest of the box. That doesn't tell us much, though. This 3 eliminates 3 here. So 3 has to be one of these two digits. 3 is next to 4 in the ratio. So this is 3, this is 4. This cannot be 4 here, which is correct. We can't have a 1 here because of the 1, 9 pair in the box. This can't be 3. This is a 6 now. That eliminates 6 from this column. So this is 3 and 8. 3 and 8 can only... 3 can only be next to 4, and 8 can be only next to 6. So this becomes a 4, 6 pair. That 4, 6 pair eliminates 4 and 6 in the rest of the column. So this can't be 6. This is 8. This is 6. What else do we have? So F is a 3 to 4 ratio. So this is 3, 4, 6, or 8 here. G is a 1 to 3 ratio. It cannot have a 2. It could be 1, 3 or 1, 3, 9. It could be 2, 6, but the 2 can't be here. So the 3 has to be in this 3 to 1 ratio, right? 1, 3, 2, 6, and 3, 9 are the only digits which have a 1 to 3 ratio. So 3 has to be here, which means this can't be 3. So this must be 6 and 8. The 6 and 8 pair. So 3 is with 1 or 9. We're not sure which. The 6, 8 pair eliminates 6 and 8 in the rest of the box. 1, 2, or 9 means this is 3 here or 6. Yep, so this is 3 or 6. D is a 4 to 3 ratio. So it's 3, 4, 6, or 8 here. One of 3 or 6 is here. And this is a 3 or 6. That eliminates 3 and 6 in the rest of column 5. This cannot be 3. So it's 1 or 9 there. We also have a 1, 2, 5, 9 quadruplet in box 5, which eliminates 1, 2, 5, 9 in the rest of the box. Therefore, this can't be 1, 2, 5, or 9. This is 3. This can't be 5 or 9. This has to be a 4. That 4 eliminates 4 here, so this is 1. That eliminates 1 here. This 6 eliminates 6 here, so this is an 8, which makes this 6. 8 eliminates 8 here, so it's 5, which means this has to be 7. This is 7. This can't be 5 or 7, so this is 1, which makes this 8. 1 cannot be any of these cells. That makes a 2, 5, 9 triplet in row 6 and box 5, which eliminates 2, 5, 9 in the rest of the row. This can't be 1, 5, or 9. This has to be a 7. Forces this to be 5. This is 7. This can't be 9. Therefore, this is a 1. 2 or 9 is with 3 or 6 here. This can't be 1. It cannot be... Well, we don't. That's all we have. We can't have a 4 here because of the 4 in the row. This is 1 or 8. This is 1 or 8. This 7 eliminates 7 here, so this is 5. The rest of row 4 is 4 and 9. So this is 4 or 9. This is 4 or 9. This digit must be a 3. Let's see. This can't be 4, 8. So this is the other 3, 6. This is 4, 8 to be here. This 7 eliminates 7 from the rest of the box and the rest of the row. So this can't be 7. Okay. 2, 5, and 9. 3, 6. 3, 6. Okay. This can't be 1 because of the 1 in the column. Therefore, this is 4, 5, 9. It cannot be 9 because of the 1, 9 pair in the box. This must be 4, 5, 7, 8, 9. No 9. 4, 5, 7, 8. 4, 5, 7, 8. This can't be 7 or 5 because of the 5, 7 pair in the row. So this is 4, 8. 7 has to be one of these two. We don't know about... Oh, we have a 4, 9, 4, 9 pair in column 9, which eliminates 4 and 9 in the rest of the column. Therefore, this must be a 5. That means 5 cannot be here. This becomes a 1, 2, 9 triplet. 5 eliminates 5 here, so this is 9. This can no longer be 9 then. We have a 1, 2, 9 triplet, which eliminates 1, 2, 9 in the rest of column 7. This can't be 9. This is 4. This can't be 4, so this is 9. This can't be 4, so this is 8. These can't be 4 or 8, so it's a 5, 7 pair. This 9 eliminates 9 in the rest of the column, so this is 4. This is 8. This 8 eliminates 8 here, so this is 1. This is 8. 1 eliminates 1 here, so this is 9 and 1. We have 1, 2, 3, 6 remaining in row 3. This can't be 6 because of the 6 in the column. This can't be 3. 9 cannot be either of these. We have 2, 3, and 6 remaining in row 7. This can't be 6. This can't be 3. In row 9... we are missing, what? 4, 5, 7, and 9. This can't be 7. This can't be 4. G's a 3-to-1 ratio, so it could be 3, 9, or 6, 2. D is a 3-to-2 ratio. It's either 4, 3, or 8, 6. Oh, okay, well, no. This can't be 8 because of the 8 in the column. Rest of column 5 cannot have 3, 6, 1, or 7. So this is 2, 4, 5, 8, 9. Okay. So what can this cell actually be? It could be 2. Right? If this is 9, if this is 2, this becomes 9 to 6. Therefore, this is 3 and 4. This would have to be 5, and that would be 8. Otherwise, if this is not 2, this has to be 2. So it's 2 and 6. Oh, either... Okay, so if this is 2, the 2 can only be here or here. If this is 2, this must be 9 to... Oh, this is 9 to 3. Which makes this 6 and 8. Which would make... Okay, so... Let's look at the possibilities. So if this is 2, this is 9 to 3, right? Which would make this 6 and 8. So this would be 5 and 4. If this is not 2, this is 2. So it's 2 to 6, which makes us 3, 4. So 2, 6, 3, 4. You have 5, 8, and 9, possibly. This can't be 8. So this would be 5 or 9, this would be 5 or 8, and this would be 5, 8, or 9. Oof. Okay. What does that mean? Oh, wait. Oops. I messed that up. Ooh. Okay, let's remove... The D, I don't know how I got that ratio wrong. The D is wrong. So, the G ratio is correct. The D ratio is not. I don't know how I got that. Okay. I think I was making it F. So that's not 3, 4, 6, 8. Okay, that's really bad. I have to go back a while. Okay, so we go to G. G is a 3 to 1 ratio. D is a 3 to 2 ratio. So we can have 3 and 2. We cannot have 3 and 2. If we have 3 and 2, that would eliminate 2 here and 3 here. This would be 6 within, trying to be a 1 to 3 ratio with 1 and 9, which doesn't work. So this cannot be 2 and 3. Therefore, we are guaranteed a 6 here. Okay, so that's what that is. This 6 is guaranteed to be here because it's either 4 or 9, because it's 1... So you have either... It's a 2 to 3 ratio, so it's either 2, 3, 4, 6, or 6, 9. Can't be 2, 3, because that would eliminate all possibilities here for this ratio. Because it's 1 to 3, right? This has to be a 4 anyways. So that's 4. This is 1. So this is still the same here. That means this can't be 1. This is 5, 6, or 8. Cannot be... this 6 eliminates 6 here. This is 8. This is 6. This 8 can't be 8. So this is 5. This is 7. Can't be 5 or 7. This is 1. This is 8. This can't be 7. This is 5. This is 7. Okay. Can't be 7. No 7 here. Okay. So again, this cannot be 2 and 3 because that would eliminate all possible. This can't be 1 then. This is a 1 to 3 ratio. 2 would be with 6. 9 would be 3. We have a 3 to 1 ratio. This is a 3 to 2 ratio. Again, 3 and 2 would not work because that would force us to be 6, 9, which is not a 1 to 3 ratio. So it's either 6, 4 or 6, 9 here. We're not sure which. 6 cannot be here. Therefore, this is guaranteed to be 6 here. Because we have a 6 in rows 1 and 2 in box 1, and 6 in rows 1 and 2 in box 3. So the rest of rows 1 and 2 cannot contain a 6. So this can't be 6. This is 6 with 4 or 9. This can't be 6. Therefore, this is 3. 3 is only in a 1 to 3 ratio with 9 out of 2 or 9. So this is 9. This can't be 9. This is 4. This can't be 3. This is 1. This is 3. These cannot be 9 anymore. This 3. This can't be 1 or 4. We have 2, 5, and 8 left, and this can't be 2. So this is a 5, 8 pair, which eliminates 5 and 8 from the rest of the column. This must be a 2. So this 2 eliminates 2 here. So this is 1. This is 2. 2 cannot be either of these cells. Where is the 2 then? In a box 3. It must be here. This can't be 7 again. This can't be 4, no 4. This can't be 5 or 8 because of the 5-8 pair in the box. This can't be 4. Therefore, that forces this to be a 1-7 pair, which eliminates 1 and 7 in the rest of the box. We have to have 5 and 7 somewhere in box 9. The only two places are here. So this must be a 5-7 pair, but this can't be 7 because of the 1-7 pair in the row. So this is 5, this is 7. That eliminates 5 here, here. This is a 1-9 pair. This 1 eliminates 1 here. Therefore, this is 9, this is 1. This can't be 9 or 1, so this is 5, which forces this not to be 5, so that's 9. This can't be 9 here or here. 4 eliminates 4 here. So this is 6. This is in a 3 to 4 ratio, so this is 6 and 8. This is 3 and 4. 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 5 or 9. This must be 7. This 3 eliminates 3 here. It's 6 and 3. This is a 5-8 pair. This can't be 5 because of the 5 in the row, so this is 8. This is 5. The remaining digits in row 3 are 1 and 3. This can't be 3 because of the 3 in the column, so this is 1, this is 3. This 1 eliminates 1 here, so this is 7 and 1. We have 4 and 8 remaining in row... in this box, in this 9 box. This can't be 8, so this is 4, this is 8. That eliminates 8 here, so this is 1 and 8. 1 eliminates 1 here, so this is 9 and 1. We have a 2 and a 6 remaining in row 7, so it's like the same. So this can't be 6 because of the 6 in the column. This is 2, this is 6. 2 eliminates 2 here, so it's 5 and 2. This can't be 7, this is 5, that's 7. We have 4 and 9 remaining in row 4. This can't be 4, so this is 9, which makes this 4. That makes this a 3. In row 9, we have just 4 and 9. This can't be 4 because of the 4 in the column, so this is 9, which makes that 4. Column 4, we just have 7 and 9. This can't be 9, so this is 7, which makes this 9. 7 eliminates 7 here, so it's 5 and 7. That makes this a 8, and this a 5. And that's the solution. Pretty straightforward. I just messed up the D ratio. Apologies for that. Pretty cool, actually. Makes you think about the ratios that you have often with the digits. So that was actually very interesting, how he used that. Very cool. Very cool puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.